When you want to make a square wave oscillator, this could be an idea. I made it with an old school 7400 TTL chip, and it's here on the board. Say, kind of breadboard, but of course the good property of making it in this way is that when it all works, you can directly convert it to, say, the definite electronic circuit. I had one comment, someone told, give this man a breadboard, but well, the way that I develop my circuits is not possible with a breadboard. Say the standard breadboard. Standard breadboard has, of course, its limitations anyway. Don't want to get too deep on that issue. The circuit again, and here is the schematic. It's in fact extremely simple. Only need one chip, the 7400 chip, two capacitors and two resistors, and here you have it all. Of course, such a chip works on 5 volts, but you can even go to 8 volts. And I found that perhaps important to tell that on 3.5 volts I had the purest square wave. So, experimental results. These two capacitors here are responsible for the frequency that the oscillator gives out. Here you have, say, a DC output, and here you have that capacitor in between, coupling capacitor, that makes it an AC output. Anyway, let's try and see. Put on the scope, and I've used for the two capacitors 0.1 microfarad, that is 100 nanofarad, and in this circuit we are now on 2 kilohertz, approximately 2 kilohertz with these two capacitors. 1.7, etc., etc. Say that's a range where it works. So, first interesting experiment is what will happen when we change the supply voltage to the circuit. I now am on 3.9 volts. I now go back to 3.5 volts. Here. And you can see the waveform is quite pure. The frequency is at 2.1 kilohertz. But now I go to higher voltages. Now I'm on 6 volts. You can directly see that the waveform changes. Here there's kind of other top. The frequency changes to 2.3 kilohertz, and perhaps you think, well, this TTL chip must be supplied with only 5 volts, but it can handle also a somewhat higher voltage. Now I go to 8 volts. I don't want to go higher. Perhaps the chip will be damaged in that case. 8.8 volts. So frequency on 3.6 kilohertz. Quite interesting, I think. Well, that was more or less all to tell. You can thus change the voltage to such an old school TTL chip to a higher level. That means a higher frequency. That also gives a lot of possibilities when you want to develop an oscillator. square wave oscillator, and of course do your own experiments. This waveform is of course not very pure here. There's, say, another time delay or something anyway. Well, of course I don't have to tell that when you are a little bit acquainted with electronics. So, changing the value of these two capacitors will change the output frequency. It will also change the waveform somewhat. Do some experiments to get to somewhat higher voltages with this setup. It can surely work, and it can be very, very handy when you need a simple square wave oscillator in the range between, say, 1 kHz and 5 kHz to drive a transistor or whatever. And you can also do some experiments with the value of these two resistors. Don't make them too high. That's my idea. Say, could be that on 10 kilo ohm both resistors the circuit doesn't want to work, but feel free to experiment. Also one of the aims of my YouTube channel. Experiments are, say, key to understand electronics. Well, let's look again to the beautiful waveforms that the circuit can make. I'm now going to do a small experiment changing one of the capacitors. It's now 100 nanofarad, but I'm going to change it to say 500 nanofarad. Let's see what happens. Frequency drops to 2.6 kilohertz. That's of course completely logical. More capacitance means another frequency, and in higher capacitance means a lower frequency anyway. That's one experiment that I wanted to show. And now again, that same capacitor of 470 nanofarad connected to paralleled to capacitor 1. So, different effects. That's interesting, of course. So, a good circuit to do experiments with, and it is extremely simple to make. Thanks for watching.